Simple random sampling. Suppose our commuting student from section 2.1 aspires to be a statistician and decides to record her commuting times on various days. She selects these days at random from the school year, and her daily commuting time has the cumulative distribution function in figure 2.2a. Because these days were selected at random, knowing the value of the commuting time on one of these randomly selected days provides no information about the commuting time on another of the days. That is, because the days were selected at random, the values of the commuting time on the different days are independently distributed random variables. The situation described in the previous paragraph is an example of the simplest sampling scheme used in statistics, called simple random sampling, in which n objects are selected at random from a population. The population of commuting days, and each member of the population each day is equally likely to be included in the sample. See key concept 2.5, simple random sampling, and IID random variables. In a simple random sample, n objects are drawn at random from a population, and each object is equally likely to be drawn. The value of the random variable big Y for the ith randomly drawn object is denoted big Y sub I, because each object is equally likely to be drawn, and the distribution of big Y sub I is the same for all I. The random variables big Y sub 1 through big Y sub n are independently and identically distributed. IID, that is, the distribution of big Y sub I, is the same for all I equals I through n, and big Y sub 1 is distributed independently of big Y sub 2 through big Y sub n, and so forth. Continuing the text, the n observations in the sample are denoted big Y sub 1 through big Y sub n, where big Y sub 1 is the first observation, big Y sub 2 is the second observation, and so forth. In the commuting example, big Y sub 1 is the commuting time on the first of the n randomly selected days, and big Y is the commuting time on the ith of the randomly selected days. Because the members of the population included in the sample are selected at random, the values of the observations big Y sub 1 through big Y sub n are themselves random. If different members of the population are chosen, their values of big Y will differ. Thus, the act of random sampling means that big Y sub 1 through big Y sub n can be treated as random variables. Before they are sampled, big Y sub 1 through big Y sub n can take on many possible values. After they are sampled, a specific value is recorded for each observation.